Okay, let's review some of the things we've covered so far. When we're graphing quadratics, that's something with the square here. We talked about the a. First of all, we said if the a was greater than 1, that it is a vertical stretch. The parabola gets thinner and thinner and stretches more towards this vertical line or the y-axis. We said if the a is between 0 and 1, that it does the opposite. Instead of stretching, it shrinks away, opens up wider from this vertical line. It's getting away from it. And we talked about some other things. We said if the a is positive, that it's going to be up. But if this a here is a negative, then we saw the parabola would actually frown. If it's negative, it frowns. How convenient is that to remember? Okay, if it's positive, it smiles. That's good. Okay, and then we started learning about this thing when we talked about the vertex, that you could find the maximum and the minimum point. If it's going negative, we're finding the maximum point. But if it's positive, like the one on this paper here, then we find the minimum point, and the vertex is going to either be at the maximum or minimum point. And then we talked about how you could find the vertex. One way to find the vertex is to find either the x point of the vertex or the y point. And we found out that if x is 0, the y-intercept, which means x is 0, that just y-intercept means that x equals 0, is just whatever this last number is, the c. Then we found out that we could also find the x-coordinate, so it will give us the y-coordinate, right? We could find the x-coordinate by using this formula of negative b over 2a. If that looks familiar to some of you, it's because it's also in the quadratic formula. So, trying to think if I want to go over that right now. No, but it's in the quadratic formula. So it may look familiar. And then the axis of symmetry is also this negative b over 2a. So this is an important thing to remember. So that's what we've covered so far up to this point. And now we're going to go one step further. I'm going to ask us to describe the domain and the range with this information, okay? You're going to see it's very similar to what we've already done. In fact, the first two steps are virtually identical to what we've already done, okay? Remember what we did last class? How to graph quadratics is we found the axis of symmetry, which is that x equals negative b over 2a, and that was the x value. And then once we found the x value, we substituted it in to find the y value. Because once you found the x value for the axis of symmetry, then the y value would also be for the axis of symmetry, because that's what we're dealing with. Well, the first steps are the same. I phrased them a little different, but they're really the same. And what I'd like you to do at this time is go ahead and write down these 4 steps, see if I can make it all fit on this graph. If I can't, it's okay on this recording. Looks like I can almost make them all fit. So describing the domain and the range of the quadratic. And here are the 4 steps. Find the axis of symmetry, find the vertex. Once you find the x, you can find the y. Use the y-intercept to find 2 or more points. Plot the points to draw a smooth line through the points. So that's what we're going to do today. And then we can easily describe the domain and range. So let's work some of this out. It says describe the domain and range, and it gives us a problem. So the first thing we want to do is find the x value, and then we will find the y value. And we already talked about finding the x value is just finding that axis of symmetry here. Put this back up. Find the axis of symmetry. Use this formula. So that's what we'll do. We'll say x equals a negative b over 2a. So x equals a negative, instead of a b, which one of these is the b? If you recall, you have an a, b, and a c. Those are the coefficients. Those are the numbers. So the b is a negative 6. Be careful. There's a negative from here that's going here. There's also a negative in front of the 6. There's 2 negatives. 2 times a is a 3. Well, negative next to a negative is a positive, and 2 times 3 is also 6. And 6 over 6 would equal 1. So we found the x value of the axis of symmetry, which is a 1. Good. Step 1 is done. Check. Now we need to find the vertex. In order to find the vertex, we need to find the y value. But how do we find the y value? We substitute the x value into this equation. So let's write it. 3 times x squared minus 6 times x plus 5. But in place of the x, we're going to substitute the 1. This becomes very simple if we just do the order of operations. We square before we multiply, right? So 1 squared would be 1. Bring everything else down. We multiply before we add or subtract. So that would be a 3. Negative 6 times 1 would be a negative 6. This is where sometimes people make mistakes. When you come to adding and subtracting, you do the one more to the left first. More to the left. So 3 minus 6 would happen before 6 plus 5. 3 minus 6 is a negative 3 plus 5 would be a negative 2. And there we have it. We have our x value, which is a 1, and our y value is a negative 2. Now this may look familiar. It's because those are the first same steps that we use when we're graphing a parabola. We found the axis of symmetry. We found the vertex. Now let's say use the y-intercept to find 2 or more points. So let's talk about why we're doing that. So far on this graph, all we found was the 1 and the negative 2. So if x is a 1, y would be a negative 2. We know that that is the axis of symmetry. This is going to divide, if I draw a line straight down, the parabola in half. But I still don't know what the parabola looks like. I don't know if it's going like this or like this. And I guess I know since it's positive, since the A up here is positive, I know it's going up. But there's still a lot missing, okay? So to describe the domain and range would be hard until I finish it. So how do I finish this? How do I do the rest of it? I need 2 other points to kind of give me an idea of what to draw. And so how would I find those points is I will take the same equation that we just used. Let me just write it here. So I'm going to take the same equation, 3x squared minus 6x plus 5. But I'm going to use the y-intercept to find 2 or more points. The y-intercept means that x now equals 0. Okay? So now the x is going to equal 0. So it's going to be f of something equals 3 times something squared minus 6 times something plus 5. But we know that something where the x was is all going to be zeros. Every time. That's what an intercept means. It's where it intercepts on the axis, and so then the number has to be 0. Okay, so f of 0 equals 0 squared is just 0. And that 0 times 3 would also be 0. And then a negative 6 times 0 is also 0. So we bring down the plus 5, and we found out if you input a 0, your output would be a 5. So let's go back to here. We know if we input a 0 as our x value, our output would be 5. 1, 2, 3, 4, 5. There's one of your dots. Now you found one of the dots, but how would you find the other one? So you can kind of predict this parabola. Here's what I want you to notice. If I were to draw a line here through this axis of symmetry, And I noticed that this point, the 0, 5, goes up 1, 2, 3, 4, 5, 6, 7 from the axis of symmetry. So on the other side, if I were to go up 7, it would be even with this. But how far over is it from the axis of symmetry? Well, it only moves 1 over. But if it moves over on this side 1, if it's symmetric, it's also going to move over on this side only 1. So I only move over 1. So if this is 0 and 5, and 0 is 1 away from the axis of symmetry, I would go 1 away the other side. This would be 1, 2. This would be a 2 and 5. The 5 stays the same. Now we have 3 points on the graph. Okay. So we did the third step, use the y-intercept. Remember, that means x equals 0 to find 2 or more points. Then plot the points and draw a smooth line through the points. So we're going to draw a smooth line through these points. There you have it. That's how you do it. And then I would say, if I were to describe the domain and range of this, I would say the domain, remember the domain is all the x values. Well, it's going microscopically, it's going like this. It's going not just up, but to the right, not just up, but to the left, albeit it's hard to see. So any point you choose on the x-axis would, in infinity, hit these points. So the domain, the x values, is all real numbers. What about the range? Well, again, it's going up and to the right and left forever, but if it's going up forever, you know it's going to hit all those positive numbers. Notice it doesn't go down forever. It has a minimum point. Where does it start going up? At x being 1 to negative 2. So y is greater than or equal to negative 2. Good. And those are the steps for finding the domain and the range. These are the steps here for finding the domain and the range of a quadratic. 4 steps. Now, I would like you to give this a shot, at least the first part of it, make sure we understand it. So looking at number 4, what's the first thing that you would do? Go ahead and tell me.